Thanks for clicking. Welcome to another Nargilus production. Today we're going to be talking about the fundamental theorem of calculus, part 1, since there's multiple parts. Okay, so today what we're going to do is we're going to find the area underneath the curve. Since we already know that the area under the curve is the antiderivative or the integral, we're going to figure out how to integrate with bounds. Okay, so the fundamental theorem of calculus can be used to evaluate a definite integral after finding an antiderivative. So suppose f is continuous on a closed interval from a to b, and big F is the antiderivative of little f, then the integral from a to b of f of x dx is equal to big F of b minus big F of a. So basically what we're doing is the following. What we want to do now is we want to take an area that's underneath the curve. Let's say whatever this is. We want to find the area of this function by integrating it and then just plugging in the two bounds that we're working with from a to b. Okay? To do that, what we do is we integrate the function, and then we plug in the top bound and subtract the answer that we get by plugging in the bottom bound. Okay, integrate the function, plug in the top bound, minus plug in the bottom bound. That's what we're going to do. That's what the first fundamental theorem of calculus says. All right, so let's try a couple just to make sure you got the hang of it. And that's really all there is to this. So let's try the integral from 1 to 2 of 3x squared minus 4 with respect to x. So the first thing we're going to do is we're going to integrate this. The integral of 3x squared minus 4 will become straight line. I'm going to evaluate between 1 and 2. 3x cubed over 3. Add 1 to the power, divide by what I get. Minus the integral of 4 is 4x. So the 3's knock each other out. This gives me, I need to evaluate from 1 to 2, x cubed minus 4x. Okay, to do that, I'm going to calculate two things. I need to calculate big F of 2. So I need to plug 2 into this and then subtract big F of 1. Plug 1 into this. Top bound minus bottom bound. So that's 2 cubed minus 4 times 2. That's the top bound if I plug it in there. Minus plug in the bottom bound. 1 cubed minus 4 times 1. And now I'm just going to do the math. So we have 8 minus 8. Minus 1 minus 4. So that's 0 minus negative 3. So that's 3. So what does this mean? This means that the area underneath the curve from 1 to 2 of this function, 3x squared plus 4. So if I were to graph y equals 3x squared plus 4, then find the area underneath that curve between x equals 1 and x equals 2, you'd get 3. Okay, that's what it means. All right, let's try another one. So we're going to integrate from pi over 6 to pi over 3 cosine x dx. All right, so we just need to integrate cosine, the integral of cosine. We're going to evaluate this from pi over 6 to pi over 3. Integral of cosine x is sine x. So now I'm going to plug in the top bound minus the bottom bound. All right, and I'm just writing this up here to help you so that you kind of understand what's happening. You don't need to write it every time. No reason to. So we have sine of pi over 3 minus sine of pi over 6. The sine of pi over 3 signs the y-coordinate on the unit circle. At pi over 3, the y-coordinate is root 3 over 2. And then at pi over 6, the y-coordinate is 1/2. So the denominator is already common. We can write root 3 minus 1 over 2. And this is the area underneath the curve, y equals cosine x, between pi over 6 and pi over 3. Okay? All right, let's try from 1 to 16, the square root of t dt. So first thing we're going to do is rewrite that a little bit. That's from 1 to 16, t to the 1/2 power. I need a power to use the power rule. I'm going to add 1 to the power and divide by what I get. This gives me, evaluate from 1 to 16, t to the 3/2, and then it's over 3/2, and we're going to flip that over and make it 2/3. All right, so now we're going to plug it in. Top bound minus bottom bound. 2 times 16 to the 3 halves over 3 minus 2 times 1 to the 3 halves over 3. Okay, the interesting calculation is this one here, 16 to the 3 halves. 16 to the 3 halves, I'm going to do it down here. I can do it in two different ways. I can either do 16 to the 1 half and cube it, or I can do 16 cubed and then take the 1/2 power. Right? Both of them, if you do your multiplying of exponents here, you're going to get 3 halves. So whichever way is easier is the way you should do it. That's the way that's easier, because 16 to the half means square root of 16. That's 4, and 4 cubed is 64. So that's going to be 2 times 64 over 3 minus 2 times 1 to the 3 halves is just going to be 1. So that's going to be 128 over 3 minus 2/3 is 126 over 3. And 3 actually goes into this. If I clean it up, 3 goes into 12 4 times. 3 goes into 6, 2. 42. So the area underneath the curve, square root t, or square root x, from 1 to 16 is 42. Finally, I have a graph. This is the graph of f of x, and I want you to find for me the integral from -3 to 1 of f prime of x dx. So normally, if I ask you for the integral of a function from between two bounds and I have a graph, I just find the area underneath the curve. But the problem is, I'm asking you to find for me the area underneath the curve of f prime, but the graph is the graph of f. So instead of doing it that way, I'm going to have to integrate from -3 to 1 of f prime of x. Now I know what the integral of f prime is, or at least hopefully I should. The integral, if I integrate the derivative, I get back to the function. Right? I get back to f of x. The integral of f prime is f. So now I want you to calculate for me f of 1 minus f of -3. Top bound minus bottom bound. So how am I going to do that? Well, this is the graph of f of x. So f of 1 is just literally on the picture. If I go right 1, I go up 1. So f of 1 is 1. F of -3, if I go left 3, that's my point at 3. So this is -2. And that's the correct answer. Okay? So you have to be a little bit careful when I ask you to integrate a function, because now you know multiple ways to go about doing it. You can actually integrate a derivative. If this said the graph, let's say this would have said the graph of, let's just erase this here for a second real quick. And let's say this would have said the graph of f prime. If I'm asking you to integrate from -3 to 1 f prime of x, and I give you the graph of f prime, then you're going to find the area from -3 over to 1. You're going to find this area, right? The area that's underneath that curve. Okay, so there's a couple things that you can do now. All right? Okay, so you got to think about that when you look at a problem like this. All right, and that's it. And as always, thanks for clicking.